Hello, everybody, and it's so wonderful to have you all here today. Today we're going to be doing a workshop on generative art. So hello, my name is Reid. I am a developer, an educator, and a creative technologist. I graduated from the Cognitive Systems program here at UBC in 2021, and currently I work as a computer science educator and a web developer at UBC Gearing Up. It's an education outreach group where we bring STEM topics to children and youth around British Columbia. And I'm also a volunteer here with the Emerging Media Lab on the COGS 300 Labs project. So today, this workshop is going to take us about 2 hours. And we're going to be starting it out by asking what generative art is. We're going to look at some examples, and we're going to explore some algorithms which are commonly used to make it. After that, we are going to have the opportunity, you're going to get the opportunity to try out some of these things yourself. I've had some fun starter programs, which I have included in this, and you're going to go and get to edit and experiment with those and play around. And then finally, we're going to look at some of the uses of generative art, and we're going to explore some questions on what this type of art means for human understanding and creativity. So, first up, what is generative art? So generative art is a medium of creative or artistic expression. It's a lot like something like painting or photography, as those are mediums of art. But the key thing that sets generative art apart from other mediums is that it is generated with the help of a computer, where the artist won't necessarily touch the canvas themselves, and instead they'll give the computer a set of instructions, also known as an algorithm, and then the computer will execute those instructions to create an art piece. Sometimes you'll hear this referred to as algorithmically generated art or algorithmic art, and it usually also involves some degree of randomness, where each time you run the program, a different result is going to be generated. And this randomness is really one of the key parts and the unique parts of generative art, because it creates this relationship between the human and the computer in where they both play this key role in the creation of the art. You really create this collaborative adventure between you and the computer. Now, I don't want to confuse generative art with generative AI. You may have heard of things like Stable Diffusion, Midjourney, or DALL-E. These are really popular lately. But in these programs, the computer does almost all of the work, and the human is usually just giving something like a short text prompt, and that is what the computer uses to generate the work. But if we think of art as really existing on this spectrum from manual towards automatic, something like paper and pencil would be totally on the manual side. The human is in control of every single step of the process. And something like generative art is going to be in the middle, and AI art is going to be on that other extreme. So AI art, the human has very little control over that process. But in the middle here, we have generative art, and this creates this really yummy zone that's right between the two, where you have this lovely creative relationship between the computer and the human. So here are some examples of what generative art may look like. You can see in the top left, we have a bunch of lines that just basically kind of curve through the screen, and you create this really nice pattern. We have things like trees that are generated really nicely, a whole bunch of dots, which you can see in circles. You have this one kind of in the bottom middle, that's one called Portal, and it's really interesting. It has a bunch of lines that kind of loop around each other in a unique pattern. And all of the ones on the right-hand side of the screen are actually ones that I have made. You can see in the top middle there, we have different mountains and things. This is interestingly, the one on the bottom right that looks a bit like a tornado, that was actually my first attempt at trying to recreate the Portal one just to the left of it. As you can see, it did not go as intended, but it did create something really interesting. On the bottom right, we have one where you're creating a flow field. We're going to be talking about those today. And the top right is actually the first piece of generative art that I ever created about 6 or 7 years ago, where it's just a bunch of small cylinder capsules that are angled across a screen and are colored random colors. And on this note of randomness, I really want to highlight the role of this in generative art. You can see in this piece that I created here, you can see that the colors, positions, and shapes of the object are all different from each other, and they're going to be different from each other every single time that this program is run. And what's really fun is when you start looking at different types of randomness. Here I've highlighted 2 different types of randomness, and please note that there are more than 2 types of randomness in existence. These are just 2 of them. You can think of the one on the left as being something like rolling a pair of dice and taking the result of that each time. So each result there isn't related or impacted to any of the previous or future results. And so you can see that it jumps around all over the place. And here I've basically just taken a line and connected all of those. And it creates something that is quite spiky, and it feels quite artificial and computer-like. But there's also another type of randomness that is continuous, where each result is connected to the ones before and after it. It's actually a continuous mathematical function that you can choose a point on that line, and what you end up with is results that look a lot more natural. You can think of something like a tree swaying in the breeze or the shape of a cloud. And this second type of randomness, this continuous randomness, even has its own name. It's called noise. And this type of randomness was originally used in the 1982 movie Tron to give the computer-generated images texture that was more interesting than a single block color. And what's fun about noise is that you don't have it just work in one dimension, it can work in 2 dimensions as well. So you can create patterns that look like this. And you can see that this is quite similar to the pattern that was used in the background of this Tron image here. And you can also see how creating this type of pattern could be used for something like generating clouds. So what you're doing here is you're actually using the x and the y values on where it is on this canvas, and you're taking the random result here, and here I have mapped that random result to just the shading of that pixel, whether it is dark or light. But you're not limited to things like color. You can also do things like size. Here is the same noise map, but it is generated using the size of the squares. So you can see that you have areas where you kind of lumps together as these nice big squares, and other areas where you have these nice small squares. You can also do things like rotation. Again, this is the same one, but now it has the rotation map. So you can see there's this nice like continuous kind of relationship as it goes along. There's no sudden jerky patterns. It really feels almost like what a natural system would look like. And you don't just have to use squares as your shape either. Here I have used noise to rotate lines, and I love this because it gives it an effect that almost looks something like hair or fur. And my favorite use of noise is when you take something like this, and instead of mapping it to the rotation, you can actually map it to a velocity in 2D space and randomly dump in a bunch of particles, which then can flow around. This is called a flow field. On the right here is a flow field that I've created that uses the image of the Milky Way as a background to determine what color the different particles are, and then I went and dropped about 15,000 particles into this thing and let it run, and it creates this really neat, organic looking, almost psychedelic type textured effect, which is really, really beautiful. And this is slightly related to another common algorithm which is used in generative art, which is fractals. So a fractal is something which is self-similar at different scales. And this following video is an animation of the Mandelbrot set, which is probably the most famous fractal in existence. And what it does is it takes that x and y value on your screen and it uses the complex number plane and basically continues multiplying it, and then you map the colors to how quickly that value scales to infinity. And it's this really, really beautiful effect that you can actually continue zooming in forever. And you can see that as you go deeper and deeper, you get patterns that seem to repeat themselves. And in the case of the Mandelbrot set, it's actually never identical, but it is very self-similar. And we also see this a lot of the time in nature. So one of the most common places that you'll see fractals in nature is trees. I think this is really beautiful because you can see that each branch of this tree looks itself like a smaller little tree. And on the right side here, this is artwork. Oh, this is the left side. No, this is the right side. Go on the other way. On the right side here, you can see that this is an artwork that I didn't make, but it's one that is so beautiful that I just had to share it. And this is a combination of using trees as well as noise to get this really beautiful organic kind of fractally branching effect. And fractals are one of the most pleasing patterns to the human eye because there's a lot of repeated information, and it's something you see very commonly in nature like plants and trees, and so we find it generally quite a soothing effect, which I love. The last algorithm I want to talk about quickly is the use of tiling. So if we look at this image, we can actually break it down into individual squares, which are actually all the same individual repeating tile. You can see it here, and it's just been rotated in increments of 90 degrees and then stitched together. So those are some of the algorithms I wanted to share with you. Before I move on, does anybody have any questions about those algorithms or wants me to go back and talk more about any of them? No? Well, then let's jump into actually making these. So did people bring laptops with them today? No? We have a single laptop. Okay, so what I'm actually going to do is then I'm going to give us a 5-minute break. If you have a laptop nearby or we have laptops that we can use, that will be what we are going to do for the next step. So now that we all have laptops, let's get started making some generative art. So I want to introduce this program called Processing, or Processing 5 JavaScript, 5JS. And it is a lovely program that you can find online, and I'll be showing it to you for a second. But I just want to go over the various areas of this first. Basically, what you're doing is you are writing code, and then that code is being executed in your browser, and it will show the results in the canvas over here. So what we can all do is we can go to, let's see if this is going to work for me. Here we go. So if you want to, oh, it's going to go back. That's rude. We're going to go to editor.p5.org, I think. Excuse me for technical difficulties. One moment as I attempt to get this showing on my screen. Okay. It just disappeared entirely. It was editor.p5js.org. Okay, we're just going to do this right. Yeah. And then up here, editor.p5js.org. And I'm just going to show you the basic setup for this, and then I am going to give you some of the algorithms that I made that you can go and experiment and edit with. So what's happening here? is, we have two basic areas on our screen. We have our code and we have the result. And you can always run your code by hitting this play button in the top left-hand corner, and it'll take what you've done and it will render it here on the right. So right now, in the default, not much is happening. The only things that I'm doing is I am first creating a canvas that is 400 pixels wide and 400 pixels tall, and then I am drawing on it a background of the gray color 220. So that number 220 is on a scale from 0 being black to 255 being totally white. And what's happening here is these two functions are the two most common ones that you will end up using. The setup runs once at the beginning of the program, and then the draw will run about 60 times per second. So it's what it does your frames, and it'll basically loop through that forever. So depending on what you are making, if you're just making something that is a still image, oftentimes a lot of stuff will go inside of setup, but if you're making any kind of animation, you're going to want to have multiple frames, and you're going to put things inside of your draw. So for right now, actually I can put things in the draw loop. What I can do is I can start adding in shapes to this. So I might want something like a rectangle, and then I have to tell the program where that rectangle is and what size I want it. So I might just put it right in the middle of my canvas and make it 100 large. Let's do this. So here it's at 200x, 200y, and it is 100 pixels large. And so you can see here it draws that rectangle for me. And you can see that for the rectangle, it's drawing it starting in the corner. So this point here is at 200, 200. I can also do things like circles or an ellipse. And I can do a very similar thing where I might say like 200, 200, 100. And you can see that now I also have a circle on my screen, and I have it at the same spot that I do the rectangle, but now it's drawing the circle from the center of that circle. And you can see that the number here for the size is the diameter of that circle. I can also do things like draw lines. Oops. So I might say line, and I'm going to start it at 0, 0, and I am going to go to 200, 200. Now, before I run this, can anybody here predict for me where is this line going to start and end from? Top left to center. Why do you say top left?
Because it usually starts top left, in order of pixels.
In order of pixels. So that is actually not usually the answer that I get, but it is the correct answer. A lot of the time, we're used to 0, 0, the origin being in the bottom left-hand corner in most math classes, but when you're working with computer graphics, a lot of the time, it'll start in the top left corner. Now, I'm going to give bonus points if anybody here can tell me why computers start in the top left corner with their graphics.
That's how we read.
TSC rendering thing with scan lines from the 50s.
Yes, I think you're both versions of correct there. Yeah, it's how we read text, right? Computers before they showed images just showed text, and we always start reading from the top left corner. And because in the original days of the computer, memory was also a really, really finite resource that had to be managed very carefully, they didn't want to have bigger numbers by starting with 0, 0 in the bottom. It means that any text would have to start at a coordinate that was a larger number at the top, and then that text would take more memory to display on the computer. So this way, you could basically just hack it by just starting in the top left and only rendering from 0, 0 onward. From the bottom left, I think that's just convention, where we usually have positive y numbers mean you're going up, and negative numbers mean you're going down, and same with x. So just so you know, it is going to be opposite maybe of what you're used to from a math class. It is fairly easy to get used to, but if you're like, why is it going the other direction on me? Just try to remember that it is because we are starting in the top left. Now, another fun thing that I can do is I can start filling this with colors. And there are a couple of different colors that I can do. So the fill function here, if you give it a value, it'll then fill any shape afterwards with that color. So what I might want to do is, if I want to fill it black, then I might give it the color 0. But I can also do things like RGB values. So if I want to fill the next one as like a blue color, right, my first number would be red, my second number would be green, and my third number would be blue. I mean, see, if I do that, then I have this nice blue circle. And I can also do the same thing with the outlines of things if I use the stroke keyword, which also will change the color of the line. So maybe if I want to change the color of line to red, I might do something that looks like this. And you can see that it actually changed all of them, even though I have it just before the last line here. Does anybody want to take a guess as why that's happening?
There's no existing precedent.
Yeah, there's nothing telling it to do anything else. Basically, whenever you tell it to like fill a certain color or do a certain stroke, it does that until it hits code that tells it to do something else. And because we are doing this in a loop, right, it never sees anything that says anywhere else. It just draws them by black by default, but if you tell it to do anything else, then it will do that other thing. Now, this was just a really basic example just to show you kind of the starter version of this and just how you generally make shapes. Do we have any questions on this so far, or do we want to move forward to the actual fun generative art stuff? Fun stuff? Okay. So what I need to do here is I think I need to restart my presentation because it decided that it just does not want to exist. So you'll just have to give me 1 second here, please. Yeah, still did that. Okay. Okay. And we'll bring this back. Okay. So let's go to the creation time. So here I have 3 different algorithms that you can use. These are all examples that we've seen so far. At the top we have one that is generally easier to get started with. It's the tiling one, and if you want to see the code for it and start editing it, you can go to bit.ly/generative tiles. If you want something that's a little bit more complicated, this one uses functions and recursion. Then you can check out the fractal tree. That's at bit.ly/fractal tree. And finally, if you want something a little bit harder, you can go to the flow field at bit.ly/flow field. If you haven't used JavaScript a lot, I probably wouldn't start with the flow field one because it does use objects and arrays. So if those, and lots of loops, they all kind of use loops. But that last one, if you've never used JavaScript before, you may want to start with some of the others because it is going to have some more specific syntax. So what we're going to do is we're going to hang out for probably about the next 30 to 45 minutes, and we're just going to go and try a bunch of these algorithms. So what you can do is, I've left some comments in a lot of the code, so you can go and you can change things, and then these links are going to come back in a second. There's also some resources. There's the reference, the processing 5 reference, which you can also find. Is this going to disappear on me again? No. You can also find the reference under the help menu and go to the reference. And this is really helpful. It's a really good reference that basically shows all of the built-in functions that you can use. There's like everything from like events, like things like where the mouse is, to keyboard functions, to different HTML elements that you can create. There's a whole bunch of stuff on shapes. There's a bunch of stuff on colors. Really great. There is also, you can go to gup5resource.netlify.app. That is the same as the piece of paper that you have in front of you. It's just a website version of that, and that just gives you some of the basic JavaScript syntax. And then finally, one of my more favorite ones, if you go to coolers.co/generate, it generates a color palette for you that kind of fits nice and well together, and you can do that. And that is another fun one. Oops, let's go back. But for now, I will keep it on this one here. I'm going to put on some music, and I will be wandering around for a little bit. And if you have any questions, anything like that, feel free to ask. And have fun. Is this any better? Fantastic. Okay, so hopefully now we can hear me a little bit better. Yeah, so we're going to talk about the why of generative art, what it can be used for, and what it means for things like human creativity. So one of the main things that generative art can be used for is animations. So this next one here it was motion capture of somebody doing kung fu, and then they took those points of the human body, and you can see they almost did a thing like we did with the flow field, where it keeps like almost an after image of that body as it moves through space, and it can create this really, really beautiful artwork. And there's a couple of different versions of this one, which we're going to look through quickly. I remember when I first saw this one, I was utterly mesmerized. Yeah, so this one takes, I think, the speed that it is moving at, and as it moves faster, it creates more particles around that point, and then slowly disappears over time. Another place that it is often used is in things like movies. So if you've ever seen The Lord of the Rings, it was one of the first movies to really use CGI at scale, and it was used to create all of the armies. And there's just about a minute of this video.
Themselves, they employed the use of a software program called Massive. It's essentially an AI simulation where you can randomize different variables of each individual agent to create a group that doesn't just feel like clones of the same model. Each agent is textured with the appropriate armor and weaponry, taught how to move and to fight through motion capture data from the stunt team. They react to sight and sound to know where to move, when to attack or to block, and then the program just runs its course. You can take more manual control if the shot demands something specific, but a lot of the large skirmishes depicted in wide shots are just the program working effectively. Then with the AI software running, combined with these digital 3D spaces, elaborate miniatures, and on-set action with all of the actors and stunt people, you end up with some of the most epic battle sequences ever filmed.
So that was one place that it's used in animation, and it is being used all over the place now, where you basically create these scenes that might be slightly randomly generated, the movement of objects, the movement of things through the scene, even like the walking and things like that. You can all create using randomness and this computer kind of co-creation with the human. This is the final one. This is another one that uses motion capture, but takes the outline of the human, and it used a machine learning algorithm to figure out where that algorithm or where that outline was, and then it maps on these textures to the human body and creates these really
to my grave. You gon' play your games and I know it. I'ma play 'em back, I'ma play 'em back. You'll make me a fool and you know it.
So that one's fun. It keeps going. I fully recommend watching the whole thing because it is very entertaining. But I want to keep moving here because another place that you see this kind of generative art used a lot is in video games. One of the basic examples is using something like that tile map that we talked about earlier to map out a level, where it won't just be like a random rotation, but you might also have different conditions for what can generate next. Maybe if I have ground, then I can generate water next and things like that. And this has been used to create entire virtual worlds. Minecraft is one of the best examples of one of these procedurally generated worlds where it takes the set of rules that the programmer inputted and said, okay, which things can spawn next to each other, where can they spawn, how high can they spawn, how can I generate these caves? And each time you do this, it is randomly generated. And it creates these really beautiful things, which we have gone on to make things like scenery with this. This is similar to the tree, which we talked about, where you can create more shrubbery and things like that. And then there's even been games like No Man's Sky, which puts all of these things together where you have basically randomly generated trees and animals and storylines, characters. The entire worlds are randomly and procedurally generated, and it creates this really interesting experience that is quite beautiful. Another place that this type of thing can be used is in art and science. And I'm going to let Dylan Beatty here, he gave a talk on this. I'm going to let him speak for about a minute or two on this topic.
I am going to talk to you about art. And all art is quite useless, says Oscar Wilde. Now, I don't entirely agree with this quote. I like this quote a lot better. The function of art is to hold a mirror up to nature. And if we want to use art as a tool to explore and understand the world around us, we can hold a mirror up to it. But before we can do that, we need to invent the mirror. And that is where science and technology and engineering come in. Because for centuries, we humans have built machines and tools to help us explore and understand the world around us. We've created scanning electron microscopes that have allowed us to see things like this. This is shards on the eyelid of a beetle. It's been there the whole time, and nobody had ever seen it until we invented machines that could take photographs of something that's only a handful of micrometers across. This is crystals growing in a dish of soy sauce. This is the stems inside one strand of a banana leaf. This amazing, beautiful, microscopic world we had never, ever seen. And we've sent machines and cameras and telescopes and people into space. And we've looked back. We've seen, our planet Earth rising above the moon. We've looked back from beyond the rings of Saturn. This is us, down here. This is the pillars of creation. This is 6,000 light years away in the Horsehead Nebula. And until we invented machines to show us these things, nobody had ever seen it.
So I really think that art and science can pair together extremely well. In all of those images that you saw, we had to take data which some kind of machine gave us, whether it was an electron microscope or something like a radio telescope or a visual telescope like Hubble, and then we've taken that and we've colored it and we've interpreted that data. Humans always interpret the world around us through, a lot of the time, visual representations of that data. And what I really love about generative art is it basically gives you this way of taking this data. A lot of the time we use random data, but you can use scientific data as well, and transforming it into something else and seeing how something works. And nowhere else do I think this is more apparent than learning math. So this is, I just want to watch the intro to this video because it was through generative art that I discovered the beauty of mathematics. And this is just an intro to a video about Bezier curves and how beautiful they can be. And I think it really captures the essence of what I'm talking about here.
Before I knew about Bezier curves and splines, my idea of a curve was very basic. It was either the classic y = x² - 1 or a circular arc. But curves that could move in all directions, that could do loops, and all sorts of things were still a mystery to me. But once you start unraveling the construction of these curves, the idea of chaining them together to form splines come naturally. They let you define a path in a way that is computationally very elegant. Properties like the tangent and normal directions of the curve let you orient objects, or construct a coordinate space around each point, which is very useful for generating procedural geometry. You can analyze these curves based on their radius of curvature, find what direction they're turning and at what rate. You can analytically evaluate their bounding box, which is useful in a lot of optimization problems, such as when doing intersection tests. We're going to take a look at how to calculate some of these things and how they collectively make up what I consider to be the beauty of Bezier curves. Bezier curves, and more generally splines, are
So I have a little bit of a secret to tell, which is that I am terrible at math. I didn't do very well in math in high school, and I think I failed 3 university-level math courses when I came to UBC. This idea of math in the abstract as just equations and numbers that you put together with paper and pencil, and you get to the final answer, you do the algebra, and you get that little box and a check mark. It just never made that much sense to me, because I lacked this intuitive understanding of what was going on. I didn't understand how you could take something in the real world and represent it mathematically. But this gray box right here changed my relationship to math, and I think it changed my relationship to science as well, because suddenly I had this little playground. I had this blank canvas on which I could put things anywhere I want. I could make any shape I wanted, and I would start doing mathematical simulations. You can do things like the flow fields that we just talked about. You can do things like gravity simulations. You can do genetic simulations, physics, chemistry, everything. And when you start seeing how you can represent the world mathematically, and you see it appear on this screen in front of you, you turn this gray box into something beautiful, and you start seeing how these mathematical rules underlie so much of what goes around us in science and in nature. And it can do it in such an intuitive and approachable way. So, to end us off, I'd love to have some quick discussions. Now, I know some people might need to run, so if you need to do that, you can go ahead. But if the rest of us, I think we can probably just form one circle. I think it'd be good. So if we all want to come and sit at the same table, I'd love to ask the question, what are some of the challenges and considerations when we create generative art? So this is what you just did. What are some of the challenges that you faced? And how do those compare to traditional art forms, such as with paint or pencil or something like that? And we're just going to discuss this for about 5 minutes. So come, form a seat together. I think I'm just going to choose this table because it has the most number of people staying.